Hello, my name is Cristian Alejandro Camperes, and in this video I'm going to talk about some of the general strategies of software design. This for the subject of software engineering management. So first, as a general introduction, we're going to talk a little bit about the software design strategies and methods. Software design is a process to conceptualize the software requirements into the software implementation. Software design is the first step in the software development life cycle, and it's a process of implementing the software solutions to one or more set of problems. Um, it transforms the client requirements into a more suitable form, which helps the programmer in coding and implementation. So we have various general strategies that help guide the design process. Um, the design strategies are mainly about organizing design activities during the course of design. And on the other hand, we have design methods that are more specific, and they provide a set of notations, a description of the process to be used, and a set of guidelines, all for using the method that we're gonna use. Here are the most known general strategies that we are gonna cover in this video. It goes from divide and conquer and stepwise refinement strategies to the component-based design. We're gonna cover each one. First, we have the divide and conquer and stepwise refinement strategy. In this approach to programming, a complex problem is recursively divided into smaller, more manageable subproblems. In this approach, we have a top-down process of successive refinements of a specification that leads to the decomposition of tasks into subtasks and of data into data structures. We also have the stepwise refinement that is a variation of the divide and conquer, where the process is carried out broken down into several steps, each of which can be described by an algorithm which is smaller and simpler. Here we have a little image where we can see how the divide and conquer strategy is represented. Next we have the top-down versus bottom-up strategies. These are widely used in the design of software. First, the top-down approach. In this approach, each system is divided into several subsystems and components, and each of the subsystems is further divided into more subsystems and components. This process of division is to facilitate forming a system hierarchy structure. The process is continued until the lowest level of the system is reached. The system is started initially by defining the system as a whole, and then keep adding definitions of the subsystem and components. When all the definitions are combined, it turns out to be a complete system. The advantage of this approach is that it has a strong focus on requirements and helps make a design responsive according to the requirements. The disadvantages are that the project and the system boundaries tend to be application specific oriented, so there is no advantage on component reuse. On the other side, we have the bottom-up approach. In this approach, the design starts with the lowest level components and subsystems, and it goes from the lowest part to the highest level. By using these components, the next immediate higher level components and subsystems are created, and we follow this process all the way to the top. The process is continued until all the components and subsystems are composed into a single component that is now called the complete system. The advantages of this approach is that it can be used to hide the low-level details of the implementation, and also it can be merged with the top-down technique. The disadvantages are that it's not closely related to the structure of the problem, and that high-quality solutions are hard to construct with this approach. We also have strategies that make use of heuristics. In most design methods, a set of heuristics can be used to provide guidelines on the ways in which the activity defined in the process part can be organized for specific classes of problems. These are generally based on experience of past use of the method within a particular domain or for a particular form of structure. Here we have a little example of usability heuristics that are defined in order to test usability. And we can have many more heuristics depending on the domain. Strategies that use patterns and pattern languages. Well, we also have this kind of strategies. Here, any form of pattern description will need to identify both the characteristic of the problem and the general solution to it. Um, Books that describe design patterns very much function as catalogs of design patterns. So a designer that wants to use a pattern first needs to acquire vocabulary of design patterns. Then he needs to be able to recognize where a pattern will be provide a suitable solution. And then he needs to understand how to employ the pattern with the solution. Here we have a little example of software design patterns. There's three different ones: the creational, the structural, and the behavioral. And the three of these ones can be used in the software design. Next, we have the strategies that make use of an iterative and incremental approach. Incremental development, often termed as rapid application development, involves approaches sometimes termed as agile methods, like extreme programming, for example. An incremental design process involves agreeing to the basic requirements, developing an architectural design, then back and forth undertaking part design and developing prototypes, testing, and evaluations, to finally implement and test the final system. Next, we have one of the classic methods of software design, that is structured design. Here, the composition centers on identifying the major software functions and then elaborating and refining them in a hierarchical top-down approach. Structured design is a conceptualization of the problem into several organized elements of the solution, emphasizing the hierarchical view of the system. Um, Structured design is generally used after structure analysis, and it produces data flow diagrams and associated process descriptions. The benefits of structured design are that it gives better understanding of how the problem is being solved. It makes it simpler for the designer to concentrate on the problem more accurately. In structured design, the most small pieces of a problem are solved by means of solution modules. These modules are arranged in hierarchy and they communicate with each other. A good structured design always follows some rules for communication among the modules. These are called coupling and cohesion. Cohesion is a measure of closeness of the relationship between the components. It defines the amount of dependency of the components of a module of one another. And coupling is a measure of the interdependence of components. It defines the degree of dependency of each module of system development on the other. Um, Structured design uses data flow diagrams first, so it can represent the process of the system. Next, the DFD representation of the system obtained from the structure analysis is transformed into a structure chart. And here we have an example of a data flow diagram and a structure chart. The first one is transformed into the second one. Software architecture is represented by a structure chart, and the structure chart is the primary tool used in structure design. In the other hand, we have object-oriented design. This is the counterpart of structure design because object-oriented design focuses and works around the entities and their characteristics instead of the functions involved in the software system, and the software solution revolves around these entities. It works with a bottom-up approach, like the one we talked about earlier, and its main objective is to improve the quality and productivity of systems analysis and design by making it more usable. It uses the unified modeling language to represent their diagrams so it can be better understood. And A software engineer that wants to understand the object-oriented design methods, first it has to understand all these several concepts. First, we have objects that are entities involved in software design. Next are classes that are a generalized description of the object. Then we have methods that determine the behavior of a class, and they are nothing more than an action that an object can perform. The encapsulation is the attributes and methods that, when bundled together, they are known as encapsulation. Abstraction is a process of taking or selecting necessary methods and attributes to specify the object. Relationships are all the classes in the system that are related with each other. Inheritance is when similar classes are stacked together hierarchically so that lower classes can reuse functionality of the upper classes. And polymorphism allows a single interface to perform tasks for different types. So if a software engineer knows these concepts, it can start working on object-oriented design methods. We also have the data structure centered design. That is a design method that starts from the data structures a program manipulates, and rather than from the function it performs. The software engineer first describes the input and output that the data structure has, and then develops the program's control structure based on these data structures. Example of methods that use this design strategy are the Jackson structure design and the Jackson system development. Last, we have the component-based design that is one of the most newest. And here a software component is an independent unit having well-defined interfaces and dependencies that can be composed and deployed independently. And component-based design addresses issues related to providing, developing, and integrating such components to improve reuse. Reused software components should meet the same security requirements as new software. Here we have a little diagram where we can see how a component-based design is done. Here are the references used on the making of this video.